This video is about the logarithm and introducing it to solve simple and initial equations. This is our early video for the study of logarithms. What it does not do is talk about the background of how this thing called the logarithm comes to exist historically and mathematically. That's not part of this video. That would be for another video. This one's purely functional in terms of what the log is and how it works. So, starting straight up with a definition. So for bases of a, so we know that if we're talking about the base of an exponential, the base a is got to be a positive real number excluding 1. The log or the logarithm function with base a is defined as a to the x. If a to the x equals y, it's the same as saying log of y to base a equals x. Okay, now have a look at how these things relate. So you can see we have a base here, a, and we have the base written there as a subscript, a. Basically the index becomes the answer to the logarithm function. Lastly, you can see where the y goes, it's what we take the log of. And so the log is a bit like the reverse of an exponential function, just like we've seen plus and minus, multiplication, division, square and square root, and so on and so on. We have something that is analogous to the reverse of something. So it undoes it, or it's an inverse process. So what you've got to realize, it says these things are equivalent. So it says equivalent there, and that's important because it's the same information just in a different form. So with 3 quick examples there, 3 squared is equal to 9, and another way of saying that same thing, the log of 9 to base 3 equals 2. So in other words, 3 to the what gives us 9, the answer is 2. Okay, as we know, 10 to the power 4 is 10,000. Writing that in log form would be log of 10,000 to base 10 equals 4. In other words, a base of 10 to what gives us 10,000? The answer is 4. If a to the 0 equals 1, which it is, it's equivalent to the log of 1 to base a equals 0. In other words, a to what power gives us 1? The answer is 0. So it's the reverse. They're the reverse of each other, exponential form and logarithmic form, and they can be used to solve simple equations and evaluate things. So use logarithms to solve for x if 3 to the x is 81. So we basically, let's rewrite that in log form. Okay, so log, so 3 is the base. We're going to take log, it's going to be the base 3 of 81 equals x. So remember, it's like saying, well, base of 3 raised to what gives us 81. Okay, that's like saying the same thing, it's the equivalent thing. Now what we can do, if your calculator can deal with bases apart from base 10 and base e, by the way, on your calculator, traditional calculators will have a button that says log, and that usually means log to base 10, which is a commonly used log. It's called the common logarithm, actually. It's the common logarithm. There's another one which you'll learn in the future, ln, that means natural log. That's log to base e. Okay, that's the natural log. That's got special properties, and it's handy to use with things like calculus, stuff you're going to learn in the future. But if yours has got a template, some calculators and software have a template where you can use any base there. This is what we can do. I've used Desmos, for example. So you can see right there that I've got log of 81 to base 3, and the answer is 4. And on Desmos, you can see if you go into miscellaneous functions on the keypad, you've got log to base A there, and you can see that you can enter in what you like there for the base. So depends on what you're using. There is a change of base rule for calculators that don't have that, but that's not for this video. So from the calculator, x equals 4, which should make sense because 3 to the power 4 is 81. Lastly, without the aid of a calculator, log of 32 to base 2. So let x equal, you need to call it x or some symbol, and for this sort of one we convert it to exponential form. So convert to exponential form. Okay, so we have base of 2, and we're saying 2 to the power what gives us 32. So the what is x. 2 to the power what? Well, 2 to the power x is 32. Well, that's pretty easy. 2 to the power 5. 2 to the 5, alright, equals 32. So x equals 5. So it depends on the type of question. This one said that the aid of a calculator, evaluate the log, so you convert to exponential form. Whereas this one, it says use logs to solve that. Okay, you might be able to do it by inspection. So some people go 3 by 3 by 3 by 3, but it doesn't say that. It says use logs, so you convert it to log form and then use your calculator or software.